Solving cubic, quartic, and square root equations. Most of the equations in this lesson will involve factoring. So if you need to brush up on factoring, look at another video or Google it or just search YouTube for factoring videos. So always check to see if the equation you're trying to solve will factor. And when we look at 5x to the fourth minus 20x squared, we can find some common factors, the greatest common factor. Both 5 and 20 divide by 5. And if you look at the x's, we can take out an x squared. So we can divide both of these by 5x squared. And if I take a 5x squared and put it out front and divide, that's going to leave me with x squared, because I had 4 and I took 2 of them out, minus, and then 20 divided by 5 is 4, and I took that x squared out. Now looking at this, at every step, think to yourself, is there some other factoring I could do? And x squared minus 4 is a difference of squares. They're perfect squares, and it's a minus. So the x squared minus 4 factors into x minus 2, x plus 2. Now that it's completely factored, set each term equal to 0 and solve. So 5x squared equals 0. X minus 2 equals 0, x plus 2 equals 0. Divide by 5, and we have x squared equals 0. Square root both sides to get rid of the squared. Normally when you square root both sides of an equation, you need to put plus minus in front of the square root on the right side, but positive negative 0 doesn't make sense, so we just leave it as a 0. Then we add 2, and x equals positive 2. We subtract 2, and x equals negative 2. Our original problem had a power of 4, which means there should be 4 solutions. The 0 counts as a double root. It counts twice, because normally when you square root both sides, you have a plus and a minus. That just doesn't work with a 0, but it still counts as 2 roots, and then the 2 and negative 2 give us a total of 4 solutions to that equation. Now we want to solve 4x cubed minus 12x squared equals 9x minus 27. We need to move all of our terms over to the left side and have the equation equal 0. So I'm going to subtract 9x from both sides and add 27. Now we have 4x cubed minus 12x squared minus 9x plus 27 equals 0. I don't have a greatest common factor. I have 4 terms. So the type of factoring that works sometimes with 4 terms is grouping. I'm going to group together the first 2 terms and the last 2 and see if there's anything I can take out. Out of 4x cubed and 12x squared, those both divide by 4x squared. So when I divide 4x cubed by 4x squared, it's just x minus 12x squared divided by 4x squared would just be 3. There's a minus right here, so I have to put a minus here. Looking at 9 and 27, those both divide by 3. And keep in mind you're dividing by a negative 3. So negative 9x divided by negative 3 would be positive. Hang on. It shouldn't be 3 we're dividing by, it should be 9. There we go. So we're dividing by a negative 9. Negative 9x divided by negative 9 would just leave an x. Positive 27 divided by negative 9 is minus 3. I knew something was wrong because I know when I do grouping that I need to have whatever's in parentheses the same. And when I had a 3 in the front, I saw that I was going to have a 3x in the second parentheses, which didn't match the first one. So that's why I knew I had made a mistake. Now, what you have in parentheses, like I just said, should be the same. So I'll write that down, x minus 3. And then in the second parentheses, the outside values, 4x squared minus 9. 4x squared minus 9 is a difference of squares. So I can factor that further into 2x minus 3, 2x plus 3. Now set each term equal to 0 and solve. And solving, then we're going to have x equals positive 3. If I add 3, 2x equals 3, and divide, x is 3 halves. Subtract 3, 2x equals negative 3, and divide, x is negative 3 halves. So my original equation was a cubed. That means I have 3 answers. This next part involves equations that contain square root. When you do equations that have a square root in the original problem, you have to check your answers, and you need to show that you've checked your answers. Sometimes a result arrived at correctly for radical equations will need to be thrown out because it does not make the original equation true. So to get rid of a square root, you do the opposite, the inverse operation, which is squaring. So I square both sides, and that cancels the square root. So we have 20 minus 8x equals x squared. I have a quadratic now, so let's move all the terms over so that we have 0 on one side. It's much easier if you keep your x squared positive, so I'm going to move the 20 and the 8x. 0 equals x squared plus 8x minus 20. Now I want to see if I can factor that. So if I look at 20, negative 20, factors of 20, I want to end up with an 8. I want to end up with the middle number. So if I use 2 and 10, I want a positive 8. That would be a minus 2 and a plus 10. So 0 equals x minus 2 and x plus 10. Setting those both equal to 0. And then solving. So add 2, x equals 2, and subtract 10, x equals negative 10. Now, when you have a radical equation, you must check your answers. You must plug them back into the original equation and see if they work or not. So let's start by checking x equals 2. Plugging that back into the original equation for x, I would have 20 minus 8 times 2. And I want to know, does that come out to be 2? So 8 times 2 is 16. 20 minus 16 is 4. Is the square root of 4 2? Yes, so that one works. Now let's try x equals negative 10. We'll put negative 10 back into the original equation for x. 20 minus 8 times negative 10. Does that equal 2? Not 2. There's an x over there, so that should be a negative 10. Sorry, I can't find my eraser right now. So we want to know if that equals negative 10. We can stop right there because you can't ever take the square root of something and end up with a negative. So we have to throw this answer out. And when you throw an answer out, you've arrived at it correctly. We didn't do anything wrong, but it doesn't work with the original equation. It's called extraneous. So negative 10 is an extraneous solution. The next equation is a little bit more difficult. Square root of x plus 10 equals x minus 2. So to get rid of the square root, we square both sides. And when I square x minus 2, be careful, you don't just square the x and square the 2. You have to write that twice and FOIL it. So on the left side, the x plus 10 comes out. On the right side, x minus 2 times x minus 2. So x plus 10 equals, and when I FOIL that, I've got x squared minus 2x minus 2x plus 4. First, outer, inner, last. I can combine my two x's, negative 4x, and again I have a quadratic, I want it equal to 0. I also want to keep my x squared positive, so I'll move the x and I'll move the 10 over to the right side. That will give us 0 equals x squared. I already have a minus 4x, and I'm subtracting another x, so minus 5x. And then 4 minus 10 would be minus 6. Now this will factor. Be really careful with this 6 and the 5. It's a negative 6. That means one of the factors has to be negative when I look at 1 and 6 and 2 and 3. So I need to figure out how to make a negative 5 with only one of my factors negative. So the 2 and 3 wouldn't work if either the 2 or the 3 have to be negative. It's going to have to be the 1 and the 6. So to make a negative 5, that's a positive 1 and a minus 6. 0 equals x plus 1 times x minus 6. Then setting each of those terms equal to 0, I subtract 1, x equals negative 1. I add 6, x equals 6. Now I have to check these. So these go back into the original equation everywhere I see an x. We'll start with the negative 1. And everywhere I see an x, it's going to look like this. The square root of negative 1 plus 10 equals negative 1 minus 2. We want to know if that's true or not. Well, just like the previous problem, I can't ever take the square root of something and equal a negative. So the negative 1 is extraneous. I have to throw that out. Now let's test the 6. Putting the 6 back into the original problem, everywhere we see an x, square root of 6 plus 10 equals 6 minus 2. We want to see if that's true or not. Square root of 16 equals 4. Yes, that's true. It's possible that both answers will work. It's possible that neither or just one. Now we're back to factoring. This time we have an x to the 4th power, but we don't have 4 terms. We only have 3. It's a trinomial. Even though it's an x to the 4th, we can still factor it like any other trinomial. If I look at 36, I want to think of all the factors of 36, and I want the pair that will get me a negative 13. Well, 4 and 9 will work if they're both negative. So normally you would write x minus 4, x minus 9. But my original is an x to the 4th. So in the parentheses, I need an x squared and an x squared. And if you're ever unsure, you can FOIL it back out, and it should come back to what you started with. X squared minus 4 and x squared minus 9 are both difference of squares. So x minus 2, x plus 2. And then the x squared minus 9 would be x minus 3, x plus 3. Now set all of those equal to 0. And if you want to skip actually writing each one of those equal to 0 and just go ahead and solve, you can do that. So this would be x equals positive 2, x equals negative 2, x equals positive 3, and x equals negative 3.